In this video, we are going to discuss sections 8.2 and 8.3. This will be series solutions about an ordinary point. The ordinary point part we're not going to talk about at all in this section or this course. This is because we get different types of points for these series solutions. We're just going to do one series solution section out of this book, or 8.2 and 8.3, which go together. It's like the beginning here. This will be like the power series that you guys had in Calc 2. We're not going to do a lot of the crazy convergence test or anything like that. We're just going to figure out how to find a solution to a differential equation that is a series. All right, so I want to remind you how to expand a series. So take a look up there at the summation that we have there. N equals 0 is our index. And that's just, it tells us what to plug in. We plug in x equals 0. And then the summation tells me to add it to my next term, which is going to be x to the first plus x to the second plus x to the third. And the ends just go up forever, right? They go on and on and on. We are going to be manipulating these things by letting some terms out of our summations and then also doing some substitutions with our variable, our index. So first thing we're going to do is we're going to learn how to shift the series. I have an n equals 0 and I want an n equals 3. So how we can do this is I'll just start letting the indices out. Okay, so I got C0. I'm going to plug in 0 first. X minus 4 to the 0 plus, then now I do C1 and I get x minus 4 to the first, and then plus C2, x minus 4 to the second, and then I'm not going to do any more because this is now where my indices, where they asked me to put it, n equals 3 to infinity of c to the n x minus 4 to the nth power. So we just moved it over. We now have this right here. This is just n's 1 through 3, 2, 0 through 2. Can't get it right, I guess. 0 through 2, right? N equals 0, n equals 1, n equals 2, and then we just left the rest of the series in there. We're going to do this quite a bit because when we add series, we want the indices to be the same. The index on both of them have to be the same thing. So we're going to want to move things around like that so we can match them. Now, we're going to learn how to add these together. A reminder, maybe you've seen this at some point, maybe you have not, but the indices have to be the same. And then for the sake of our x's here that we're going to have in our problems, we're going to want to match their powers. And this is going to make more sense why later once we're actually solving a differential equation. So for now, this first step is going to be like, why are we really doing that? And then that will make sense later. Okay, so let's take a look at this sum here. We're taking those two summations, and I told you guys to add them, these indices have to be the same. And then for the sake of what we're going to do, we want these two to be the same as well, and we're going to go for x to the k there. So with that x to the k, what we're going to do is we're going to do some substitutions. And I want it to be an x to the k, so I'm going to call k n minus 2. Well, using that exact formula that I just wrote down, if I add 2 on both sides, I get k plus 2. So I'm going to use this. I'm going to box it to make it look different. And also the problems that we're about to do in this section are very long. So I like to break them up with boxes and stuff like that because if not, it just looks like a confusing mess. So the first thing I'm going to write here to help us, we're going to call the sub indices or sub-index maybe, I guess, since it's per problem, per section, they're not together. Sub-index here, so we do it for there, and then we're also going to do here, so I'm going to draw my box, we're going to do k equals n plus 1. I did that exponent. This tells me n is going to be k minus 1. All right, so there are my substitutions, and what I'm going to do is just sub them. So I have the summation, okay, n equals 2. In my box right there, it says k equals n minus 2. So if I want k, and I have n is 2, I plug 2 in. 2 minus 2 is 0. So we get k equals 0 to infinity. That doesn't change. Now I have to sub all these. N becomes k plus 2. If I plug into k into here, k plus 2 minus 1 is k plus 1. Then I got c, k plus 1. And then I got x to the k. That's what I wanted. Now I'm going to add this. And I got to do k now. And n is 0. That's where we're starting. I plug it into the formula. I get k equals 1 to infinity. And then I got c, and I replace. That's k minus 1 x to the k. All right, we are almost there. We got x to the k matching. That's something that I'm telling you that's going to be important. So we did that. The next step that we're going to do is we are going to let out terms. All right, we want to match our indices now. I have a k equals 0 and a k equals 1. So for this one, I'm going to let out k equals 0, and then this one I'm not going to do anything, so I just put an x. So I let out k equals 0. So if I plug in 0 for each k, I get 0 plus 2 is 0, or 2. 0 plus 1 is 1. I get 2 times c, and I'm plugging in 0. I got c to the first, and then x to the 0. I guess I'll put that in there, but that's just a 1. Plus now, that's the only thing I had to let out. I told myself by writing that in that middle step there. Then we have the summation of k equals 1 to infinity. I let out 0. That's why that's gone. And then we got k plus 2, k plus 1, c, k plus 1. None of this changes. X to the k. Plus, now this is the same. K equals 1 to infinity of c, k minus 1, x to the k. We can now add these together. They have the same indices. And then also they have the x to the k, so I'm actually going to factor that out. So I got c1x, or it was x to the 0, so it's gone. Plus, now I can write those two under one summation. And I got k plus 2 times k plus 1 times c to the k plus 1 plus, and then it's the other one, ck minus 1, and all this now is times x to the k. That's what our goal is right now for these problems. This is what I want to see in the homework is written out like this, where you sub your indices and then let out terms and then add them together. This is an intermediate step. You're going to actually have to do this. This is the beginning of the next problem. Actually, it's the middle. You have to do a little bit, then you'll get here and you'll have to work this out. So I'm trying to pull out a big giant chunk of the problem to let you practice before we get to it. All right, so I'm going to do one more summation here. All right, so I have 3 now, and we do this the same way. First, we're going to do we're going to sub our index. So we're going to do one for each one. So k equals n minus 2. I pulled that from here. I want that to be a k. So n is then equal to k plus 2. All right, I'm going to box this to kind of break my work up. This next one, it's already an n. So I'm going to do k equals n, and I'm going to box that. It's just a straight conversion. It's nice and easy. Same thing for here. I still write it in. That way in my work, we're not going to do a whole lot of examples of these big problems because they take so long. So I want to make it very clear in our writing so you can see each step, because that's going to be the most difficult part, and these problems are going to be super long, so it becomes a very numerical, alphabetical soup. So there's our indices. We're going to do that. We're going to be very clear in our work. And now I'm going to do my subs. So I get the summation of, okay, n is 2. If I plug that in, I get 0. So k is 0 to infinity. And then I replace my n with k plus 2. Then I plug k plus 2 minus 1. That's k plus 1. C to the k plus 2. X to the k. That's what we wanted. Right? Then everything here, I'm just replacing all n's with k's. Some books, if you look a lot of this up, they won't actually change they'll just leave them n's. I like to change them to k's because I think it's easier to make the substitutions. The other curriculums other examples that I've looked at in the past, they don't do that, and I've gotten lost. So I like to change to the k. Right, so now I have that, and I would be able to add all those together if they have the same indice. Right, so now we are going to, what did we call it above? Let out terms. Right, and I like to write what each one's gonna let out. Okay, we have k to the 0, k to the 1, k to the k equals 0, not to the 0, k equals 0, k equals 1, k equals 0. We can make them all k equals 1. So this first one I'm gonna let out k equals 0, this one there's nothing, and this one I'm gonna let out a k equals 0. All right, so we get, if I let that first one get 0, be 0, I get 2 times 1. So that's 2c2. X to the 0 is gone, so I'm not going to write that. That was k equals 0 for the first term. The middle term, middle summation, I'm not doing anything. Third summation, I'm letting out k equals 0. So I get plus c0, and then x to the 0 is 1. So I'm going to leave that alone. Now I get to write all my sums in and change the indices where appropriate. So this is k equals 1. I have k plus 2 times k plus 1 times ck plus 2, x to the k, minus 2. Nothing changed on this one. None of them changed, I guess. We already let out the indices, except for we changed the k zeros to 1s. And then plus our summation, k equals 1 now to infinity of ck x to the k. So now I can add all those summations together, leaving me with 2c2 plus c naught, or c0, plus the summation of k equals 1 to infinity. I open a bracket, k plus 2, k plus 1, ck plus 2, minus 2, 2k, ck, plus ck, and then all that's going to be times x to the k. Oof. Okay, so that's what it's going to be in the middle of the problems that we're going to be working on. So you'll have to chunk it appropriately. So I would focus on this before going forward in your videos. It is a whole lot. You'll be able to tell when we get to the other problems. So I would keep going here. So check out this next part. So we're going to do derivative of these series. This is great. You'll be happy with this. If I think about the summation, I'm going to do a little note here, and then you'll see the quick way, and we won't have to actually do it this long way ever again. D dx, if I write this sum out, okay, I got 5x to the 0 plus 5x to the first plus 5x to the second plus 5x to the third, and it goes on forever. Now, the derivative, we know, just distributes over summations. So this constant's going to be a 0. 5x will just be 5. Then I got 10x plus 15x squared plus, and then we'd have what, 5x to the fourth would be 20x to the third, and so forth. So the whole point of this is that if I want to do a summation, if I want to take the derivative of a summation, I take the derivative of the inside. That's what we did. So this is equal to the derivative, the summation from 0 to infinity of the derivative of the inside. So 5x to the n. N is just treated as a constant. So this is equal to the summation of n equals 0 to infinity of n, or 5n rather, 5n times x to the n minus 1. I just lowered it. It's the power rule. So we won't have to do all this mess here in the middle. All we're going to have to do is take the derivative of the argument, the thing that we are summing. All right, so we have one more here. I just want to show you one more time here. We don't need to write all that out. All we have to do is, okay, here's the summation. Oh, I wanted to make a point. Let's go back up here. If you notice here, this is the same exact thing as this. Notice, because if n is 0, we'd plug it in here and get a 0. This happens every single time with the derivative. Or not every time. That's a lie. Not every time. In these problems, it's going to work like that every time for the problems that we're going to be focusing on. And it's because we're dealing with this polynomial type answer. So when we're doing the derivative, we could raise the indice because plugging in a 0 doesn't change anything. So the same thing here. But I don't have to think about it now because now we have it. N equals 1 to infinity. And then I just take my derivative. These are constants. N and n minus 1. The n minus 2 comes down. Cn is still just a constant. And then this is x n minus 3, down 1. I didn't mention this. It's come up a few times in these problems at Cn. I just kind of, I guess, have went over it pretty quick. But those Cn's that show up, they're just numbers, just a different number. Usually a coefficient is what we're dealing with there. So please don't let that trip you up. This is our derivative. That's what it looks like we would be done. We are going to take the derivative of summations, and then we're going to do some plugging them into DE, and then we're going to get a problem like this, and then there's a whole other page of work after this point. So this is the end of this video. I would get this down in your homework before you do the next part, because this is required in the next part. If you can get this down, the next section, the actual end product of why we're doing this, won't feel so daunting and won't be so overwhelming. So please take your time, do this. Give yourself some grace. We don't do this a whole lot anywhere. I've taught all the way up and down. I've taught middle school math all the way through high school, through all college math. I've seen them all now through differential equations. And I don't know where they really squeeze these in. We kind of talk about them in Calc 2, but not extensively. And then usually it's in a rush because it's at the end of the semester. So give yourself some grace in understanding these. Watch this video a few times. Work the homework problems. Rework the homework problems. You always want to do that more than once. Work them and stay away from the key as long as you can. The key should just be a check up front. Should not be something that you have as a companion when you're working with your homework. Your homework should be you working on it, and then you're checking it with a key. If I've given you a key. At this point in the homework, I have been given keys that may change in the future. So if I use this video again in the future, I'm smiling because I'm trying to keep myself from a trap in the future. But use the key to help you, but get practice with this before you move on.